Hello everybody. Today I'm going to be going through questions 1 to 10 of the LANTITE Numeracy Practice questions. Just let me know if you need a little bit more clarity with any of the answers that I've put down. So, to start off, this table shows different levels of gym membership. What is the total cost for the first year of a silver membership? So we're looking at silver, so we're looking at the values here and here. So you have to pay the joining fee first. So that is $40. And then you need to pay a monthly fee. And how long do we pay that monthly fee? The amount of months that it asks for in a year. It's 12 months in a year. So 12 times your monthly fee of $20. We should know that 12 times 2 is 24. So 12 times 20 will be 240. So then all we need to do is add the two together. 40 and 240. 40 plus 240 equals $280. So that is the total cost for the first year of a silver membership. Now it's asking us which formula do we use to calculate the total cost for n months, where n is any number. So it's the same thing that we had just done in the previous question. We had a joining fee, we had monthly fee, and we had the number of months. So n, number of months times monthly fee, and then we add the joining fee to that separately. So that means that joining fee can't be in the brackets, so this one is no good. Joining fee has to be kept from monthly fee that multiplies by the number of months. So this is the right answer. This top one, no good. That plus sign is not what you want. You don't want to add the number of months. You have to multiply the number of months by the monthly fee. And for the bottom one, it's given us too much information. Yes, there are 12 months in a year, but we're multiplying by the number of months. It's not always going to be 12. The question could have asked for 24 months. And then we need to make sure that it's joining fee plus monthly fee times 24, with 24 being our n, which is exactly what B is showing, and that's what none of the others are. So B is the answer we're looking for there. For question 3, it says Sam is considering joining the gym and paying for a 3-month membership. So let's just do the things that we were doing before. And how much more would Sam pay at gold compared to basic level? So we need to make sure it's joining fee plus the number of months, which is 3, times by the monthly fee. So for gold, for $50 joining fee plus 3 months of $25 a month. 3 times 25 is 75. So we need to do 50 plus 75. 7 and 5 is 12. It's $125 for gold. Now if we're going to be doing basic, our joining fee is $20. And then we need to have 3 months worth of $10 a month. 3 times 10 is 30. 20 plus 30 is 50. And then we need to look at the difference between the gold amount and the basic amount. So 125 minus 50. 5 take 0 is 5. 2 take 5 can't be done. 12 take 5 can. It's $75. So Sam would pay $75 more at gold level compared to basic level. Okay, an infographic, trying to use the information that we got here. So, first question, more than 12 million people in Australia in 2016 were male. So here's the amount of people in Australia in 2016. And it says that 49.3% were male. So we can convert percentages to decimals by dividing by 100. 49.3 divided by 100 to make it a decimal. When you divide by 100, you move the decimal 2 spaces to the left. So our answer will be 0.493. And then that number can be multiplied by the 23 million. And that will get us our answer. Now I've only put the rough 23,400,000 there, but you'll be able to see that it will end up being less than 12 million. And also just a very rough thing to maybe help you in future for questions like this. This number here is obviously very close to 0.5, just like that number there is very close to 50%. 50% is half. Half of 24 million will be 12 million. So to say that there's more than 12 million, it would only be possible if we had half of 24 million. We've got less than half of less than 24. So obviously it has to be less than 12 million. Okay, next question. The number of people aged 15 years and over was more than 5 times the number of people aged 14 years and under. So here's 15 and over. Here is, right there is 14 and under. So for a start, let's just multiply 18.7 times 5 to see what that number looks like. You end up putting that in your calculator and you will get 93.5. Now if you add these two numbers together, do you get 93.5? You will not. You'll get less than that. 65.6 and 15.7. 6 and 7 is 13. 5 and 5 is 10 plus 1, 11. And then 6 with 2 ones makes 8. So we would need 93.5% of people at least for there to be more than 5 times as much as the 18.7, 5 times as much of those under 15s, which we do not have. So when it asks the number of people aged 15 and over was more than 5 times the number of people aged 14 and under, that is not true. And the last one, approximately 1/3 of people were not born in Australia. Well, if you know your numbers, you'll be able to see that this fraction actually means 2/3. But if you didn't know your numbers, just know the relationship that you need between fractions, decimals, percentages. 1/3, 1 out of every 3. If you type this into a calculator, it will give you this. So it'll be 3, 3, 3, 3, 3. That is also equal, obviously, when you need to multiply by 100 to make it a percentage. And when you multiply by 100, that means you move the decimal 2 to the right, which means the percentage would be 33.3%. Is what 1/3 is. Now, again, you should hopefully be able to see a relationship between this number, which means 1/3, and that number, which means 2/3. If you don't, please type in 2 divided by 3 into your calculator, and you will get this. No matter where your last number is, it will be a 7 because it will round up. And so what this infographic is trying to show you is that 2/3 of people were born in Australia, and that means 1/3 must be born everywhere else. Now, this doesn't give you all the information, it only tells you the top 5 countries of birth. So there'll be some people born in Japan, and maybe Papua New Guinea, and Vanuatu, Tonga, Solomon Islands, America. There'll be people from all over the place. The only thing we're told is that 2/3 are in Australia, which means 1/3 has to be outside of Australia. So when it asks you, is there approximately 1/3 of people who were not born in Australia? That is absolutely true. So now there's further questions on this. Which of the following values is closest to the average yearly gross household income? So we've got our weekly amount, but we want to know yearly amount. So we would then need to get that weekly amount, $1,438. We need to times it by how many weeks there are in a year to get the yearly amount. How many weeks in a year? Hopefully you know that is 52. And I'll just put it in on my little calculator. 52 times 1,438. And we will get our answer. Sorry, I'm just getting my calculator going. 52 times 1,438, 74776 is the answer I got. And that answer is obviously very close to D, 75,000. So the correct answer there will be D. A surf shop has surfboards for hire at $15 per hour or part of an hour, up to a maximum of $60 per day. What is the cost of hiring a surfboard from 9:30 a.m. to midday on the same day? So this one is not that complicated. $15 per hour, and from 9:30 to 12 is 2.5 hours. 2 hours will get us to 11:30. Half an hour will get us from 11:30 to midday. So 2.5 hours as a decimal is 2.5. So you can put that in a calculator, or you can just do it somewhat manually. 2 lots of 15. 15 of 15 is 30. The half of 15 is just 15 divided by 2, which again you can put that in a calculator, it will give you 7.5. Add the two together, 37.5. Again, this can all just be done straight with that first calculation. 15 times by 2.5 will get you that answer. So it will cost $37.50 to hire a surfboard for the 2.5 hours from 9:30 a.m. to midday on the same day. A 3,000 meter running course has got 3 drink stations, and it says there's equal distance between them all. What is the distance between each drink station? Now, a key thing here, it says that there's station 1, station 2, and station 3. So here's the start of the race, and then you've got station 1, station 2, station 3, and finish. And it is saying that the distance from there to there is 3,000 meters. So all we need to do is and it says that they're equally spaced apart, you just need to do 3,000 meters divided by the amount of sections that there are. That's 1 section, that's 2 sections, that's 3 sections, that's 4 sections. And by sections, I just mean between my little markers that I've got here. From the start to the first drink station is station 1. From the first to second, station 2. Second to third, station 3. And from third to the finish is station. Third station to the finish line is the 4th section. If we do 3,000 divided by 4, that will get us our answer. 4 in 3 doesn't work. 4 in 30 is 7, remainder 2. 4 in 20 is 5. 4 in 0, no good. 750 meters each one. And we know that because, as we just figured out, 4 lots of 750 meters will be our 3,000 meters. So the answer here is 750 meters. A very important thing is to look at the units it gave you, where it's asking for in the answer. If it wanted the answer in kilometers, then we've got to make the conversion from meters to kilometers, which is divided by 1,000, which means it's moving the decimal 1, 2, 3 to the left, which would make it 0.75. So keep an eye on what units it's asking for. So there's our answer in meters, there's our answer in kilometers. Question 8. Student council at a school conducted a survey of waiting time at the canteen. Table shows the waiting time for 183 students, and it mentions them all in that column there. How many students waited for at least 10 minutes? So it's got to be 10 minutes or more. Or sorry, not 10 minutes or more. More than 10 minutes, at least 10 minutes. So this is from 10 to 12. That student there, and these ones there, and these ones there. They're all more than 10 minutes, as we can see by what is on the left-hand column. So we just need to add them up. 4 plus 3 is 7, plus 2 is 9. There was 9 students who were waiting at least 10 minutes. Now it's asking us some more questions. The median waiting time was in the interval 4 to 6 minutes. Now median, if you can remember, means the middle value. So for an even number, let's say if there were 8 students, median number, 4, 5, 6, 7, 8. The median number for an even number is the middle 2. The median number for an odd number, like 5, is the middle person, where there's the same amount of people either side of the middle person. 2 on each side there. Just like for the even number of people either side of those middle 2. 183 is even. So we need to find who is the median person. And just like what we do with 5, if we did 5 divided by 2, we get 2.5. We round that up, and that will get us 3, and that's the median value, the third person. We do the same thing with 183. 183 divided by 2. 2 into 1 doesn't work. 2 into 18 is 9, with 0 remainders. 2 into 3 is 1, with 1 remainder. 2 into 10 makes 5. If we now round up this number, just like we did from 2.5 to 3, we get 92. So the 92nd person is our median value that we're looking for. So we need to add these together, or keep adding them up until we get to the 92nd person. 8 plus 26 will give us 34. We have not yet reached the 92nd person. 34 plus 59, we'll be getting close then. 34 plus 59, 9 and 4 is 13. 3 and 5 is 8, plus 1 is 9. 93. We have definitely reached the 92nd person. The 92nd person must therefore be in this category. So when it says the median waiting time was in the interval 4 to 6 minutes, that is true. Next question. The mean waiting time can be estimated by dividing the total waiting time by 8. Now, that can be an estimate, but in this instance, it's not so good. It's not so good. So, yes, it is mean means average, and the average waiting time can be a lot of the time looked at by getting all the times, all the values, and then dividing it by your middle value, which, as you can see, 8 is in both of these. However, this can only work when the distribution of students is similar. But the distribution of students is not that similar. The median value was only at the 6 minute mark, or less than 6 minute mark. And we can see that there's a lot more students in this top half compared to in the bottom. A lot more. Which means that just like the median value was only part of the way down the list, it wasn't in the middle here, we can see that this will not get us a good estimate. This will get us quite a poor one. So the mean waiting time cannot be estimated well by dividing the total waiting time by 8. So that, in this instance, is false. Question 10. In 2018, more than 3/4 of the students at the school were located in the 2 highest quarters. So we're looking at 2018, and it's saying more than 3/4 of the students at the school were located in the 2 highest quarters. So it's saying school, so it's not saying Australian distribution, it's saying the school one. So we're looking at light blue, more than 3/4. 3/4 as a decimal is 0.75, as a fraction 75%. We just need to multiply it by 100 to go from decimal to percentage. You can get this as a decimal just by typing it in your calculator, 3 divided by 4, because that's what a fraction always is, numerator divided by denominator. So if we're looking at the school, which is the light blue, we're looking at 26 and 61 as our top two, as our 2 highest quarters. 26 plus 61 equals 87, which is more than 75. So because 87 is more than 75, that means there was more than 3/4 of the students at the school in the 2 highest quarters in 2018. So that is true. Next question is the distribution of students at the school. So again, we're looking at school. Across the quarters was more similar to the Australian distribution in 2012 than in 2018. So it's asking us to compare school and Australian in 2018 and in 2012. And it's hypothesizing, well, it's asking us, I guess, what's saying the statement that it was more similar in 2012 compared to 2018. So we're looking at the differences between the numbers. 25 and 9, the difference is 16. 23 and 25, difference is 2. 28 and 25, difference is 3. 40 and 25, the difference is 15. So all I'm doing is getting one number, take the other. Here the difference is 22. Here the difference is 15. Here the difference is 1. Here the difference is 36. We should be able to see quite clearly that the numbers in 2012 seem to be a bit smaller than the ones over here. We've got one in the 20s, we've got one in the high 30s. Here you've got 2 very low numbers and then just 2 teens. So the distribution was definitely more similar to Australian in 2012 than in 2018. That is true. Last question. The number of students at the school in the upper middle quarter decreased from 2012 to 2018. So number of students at the school in the upper middle quarter. Here's upper middle. There's upper middle. And it's talking about at the school. So again, we're talking light blue. So this one here and this one here. So 28% in 2012. That's in 2012, so I'll just put a 12 over here. And then in 2018, it's 26%. However, this is not the same amount of students in both years. There's 172 in 2012 and there's 495. So we need to figure out what is bigger, 28% of 172 or 26% of 495. And again, that's just done by multiplying the decimals, 0.28 and 0.26. So if you do 0.28 times 172, and if you do 0.26 times 495, just very roughly in my head, I'd say this one's about 125 and this one's about 50. But yeah, if you just use a calculator, that will obviously get you the answer. There's my little approximate squiggle. So clearly the 0.26 multiplied by the 495, 26% of a far larger number there compared to that one there. 495 will be our answer. So that means that there was definitely a greater number of students at the school in the upper middle quarter in 2018. So when it says did it decrease from 2012 to 2018, No, it did not. It's gone from 50 up to 125, approximately. So there's the solutions for the first 10 questions. Hopefully it was helpful, and if you've got any concerns or issues or queries, just please leave it in the comments below. Thank you so much.